Okay. Welcome everyone. Today we are starting our second session of learning Kubernetes. Today and yesterday we covered these slides, and there are a few leftover slides. So let us continue from there. And yesterday we were here, like even we went through these slides, and now the whole as you saw in one of these previous slides here, Docker is the basis of packaging your application, which will have your business logic or your algorithm, whatever code you have, you are going to package it as a Docker container, like one single Docker container or an image. That if you want to scale up and down from 1 to 1,000 based on the user load, that is where the Kubernetes shines, right? Because we cannot predict how many users are going to be using it at 4 a.m. or at like 10 a.m. The load will be varying, and then we have to add more resources or bring down resources. All those things the Kubernetes cluster is going to do. But without a container, Kubernetes cannot run. Even though Kubernetes is a hugely complex orchestrator, which has got its own health checks, self-healings, load balancing, and all those capabilities, the whole point of Kubernetes is to orchestrate containers. So a bare minimal knowledge of how to build a container is very necessary. Okay, so now let us see the differences between a Docker container and a virtual machine, because some of you might have worked with virtual machines. So in this right side image, if you see left side, in a virtualized infrastructure, we will have a physical compute server, and then you will install this hypervisor or the host OS. Generally in corporations, large corporations where they have their own data center, they'll install VMware, or else in Linux also we can have RHEV, and in Microsoft you have Hyper-V, which is the hypervisor layer. After you install that, then you can install a Linux or a Windows virtual machine onto that. Okay, so you'll have a virtual machine, and then you'll have its own libraries, and then you'll have installed the app one. Now this guest OS can be Linux, and this can be Windows, and this can be Linux. So on a physical server which has got hypervisor, you can have, like I've seen, like in one of the previous companies, we used to run 200 virtual machines on a physical server. But the servers are like huge, like they'll have like multiple CPU sockets, and each will have like 16 cores. So in total they will have like 32 cores or 64 cores. So we can comfortably run like 100 to 200 virtual operating system on a host. But then the servers will cost like $20,000, $50,000 to $100,000, right? But then the management is easy. When this guest OS is being installed or rebooted, this guest virtual machine will not even know that. So they are completely isolated. Okay. But if you compare to the Docker world, the way it runs is you can have infrastructure, then optionally you can have a hypervisor or a optional virtual machine, and then you can install Docker. Because if you have an optional virtual machine, then you can manage easily. Like you can take snapshots and you can reboot and you can do all those things. But then uh, one of the best way to use Docker is not to have any virtualization layer. eh, Based on the infrastructure, install a physical Linux server on which you will install Docker. And then when your application is packaged with Docker, you can have your applications and libraries packaged in Docker, and then you can run as many of them. Now, one basic difference, fundamental difference is that if you see here, there's a guest operating system for each of the application it has to run. And this guest operating system, whether it's Linux, maybe it is like up to a GB or few GBs. Windows will be like tens of GB, like 5 GB to 15 GB. And as these operating guest virtualized operating system are isolated and they don't know about each other, each operating system should have its own full blown operating system. Okay, so this is many GB, and each operating system needs few GB of RAM for the kernel to run or the operating system to run. And boot up time is just like our laptop or desktop booting up. It will take like anything like 15 seconds to a minute or two. But here in Docker, there's only one operating system, and the these Docker containers are small. Like some of them are as simple as 10 MB, and large one will be like 500 MB. So you are saving on the disk space to begin with. And the second thing is, as we discussed, the guest operating systems reboot time is in like half a minute. But here in Docker, reboot time is as fast as it can kill the process and restart. So they're all in milliseconds only. So I can restart or scale up if you want, like say 1,000 Docker containers, you can start them in less than a second. But then if you can, I don't think you can even fit 1,000 virtual machines on a physical host. Maybe a couple of hundred, and even if it is still, even if it fits, for all of them to start, it will take many minutes. So that is the second difference. So Docker saves on the hard disk and the CPU and memory, and then the startup time is very low. Okay, and then the containers are also isolated from each other, even though they share the same um, virtual CPU also. Okay, and then creating a Docker image is very easy. There's just a couple of commands which we are going to see in a lab tomorrow. And then you only need like one operating system to run. Even if you want to run like 1,000 Docker containers, one Linux kernel or a Windows operating system is sufficient. Okay, so a basic knowledge of how Docker works and what is the difference between a Linux virtual machine is needed, which we are going to see soon. And then even this whole idea of Docker container is like not new, even though the Docker brand name and the way with which the containers are created using this Docker Inc. Is new. But then they exist, the idea of Docker existed from 1970s. The idea of taking your application and then bundling it together in one package, whether it's a tar file or a zipped file, that idea is old, and there was many people have implemented that from the past, like even 50 years ago, right? But then Docker company became very famous because they could create lots of automated tools and training, and then they also created this Docker hub so that anybody can go and host their containers for free with basic like with the minimal whatever the options they give. But then if you there's a paid model where you can use more based on however much you pay. Okay, so that is the basic difference between Docker and virtual machines. Any questions?
Uh, yeah, Jay. So when you say containers have better CPU and memory than virtual machine, so
Yeah.
are you talking from because they don't have their own operating system, and that term you are talking, or is it like some other way you are telling that they are saving the CPU and memory?
Yes, that is one of the ways, because Docker
Okay.
itself doesn't have an operating system. There's like only one operating system below Docker runs, and you can have hundreds of Docker containers. So you are not installing hundreds of operating systems, right? So
Okay.
if you go ahead.
Yeah, yes, please continue. So, but yes, but like in the case of VM, you will not you will make one virtual machine very powerful. So you will make it to handle high production load. So you don't need like 1,000 virtual machine, but generally containers used to be of a small size. So that's why we scale out to a large number, right? So at the end, from CPU memory point of view, I feel if you have to handle the similar load, you will require the similar computing power. From CPU memory point of view, I think they both work in the same. I mean, at least in my experience, I try to understand it many times. But if you keep container also of very less memory, at the end of the day, they will not handle load, and then you have to scale out the load. And then scaling out the containers will create another complication. They need synchronization, thousand things. So sometimes I feel like if you have to handle very high load, virtual machine works better than these containers.
No, not in my experience, because see, you are saying in a large virtual machine is better than like Docker container, right?
Yes, if you have to handle like millions of calls or something like that,
Yeah,
then you have to run maybe like 10 virtual machine. And like if you have to talk in the term of container, then maybe you have to run hundreds of containers to get
correct,
that.
correct. So
So
now,
if you
no wait, you said tens of virtual machines if millions of people are using, right?
At the end of the day, from the computing power of point of view, you have to
Hmm.
give the similar CPU memory, whether you are giving it to virtual machine or whether you are calculating it by container. So if you are, computing power and memory, you have to give the same only, right? To process the similar load.
No, no. Let us assume no. Let me explain. There are two ways to look into that. See, let us say you are having 10 guest operating systems here. Okay. So let us say for the guest operating system, you are giving two CPU and say 4 GB of memory for the operating system only. Okay. And let us say you are running 10 large of them, right? So you are already wasting there 40 GB of memory and then 20 vCPUs,
Okay.
right?
Yes.
Step one. And if you have this, how will you do auto scaling and scale down? Your wastage will be humongous. Let us say you have 10 rock solid large machines, and let us say at 4 a.m. the load is 10 percentage, and at 9 a.m. the load is 90 percentage. So you thought, okay, I'll give you 10 large virtual machines. Okay. So now at 4 a.m. you're wasting 90 percentage of the CPU,
But
right?
we can shut down VMs also, right? Like
Ah,
we turn off,
okay.
we
Did you work as a Linux administrator ever in a data center? It is
no, no,
not
no, I didn't
realistic.
work as a,
It is not realistic.
okay,
People don't do that. In my
okay,
experience, I
okay.
can tell you, I've been a Linux administrator for more than 20 years. Okay. I've set up
Okay.
tens of thousands of Linux servers. In no company, in a production environment, a Linux administrator or even the director of the data center will say, "Hey, look, at 4 a.m. The servers are underutilized. Go and shut down." And say 8 a.m. the load is increasing. Go and boot it up. It has never happened in my 20 years because a resource time. I mean, the person resource time is more expensive than a server compute time. Okay, so nobody want to waste time on waste people's time. People don't mind like losing $100,000 worth of compute in a data center rather than hiring a $100,000 person to manage it. So it's a humongous wastage of resources. So this is the
Okay.
disadvantage of using a virtual machine, because of which Kubernetes is winning. In Kubernetes, I can configure it. Okay, that minimum there should be 3 pods. Maximum there can be like 1,000 pod. Then based on every second, Kubernetes cluster will say, okay, how much is my CPU memory disk usage? Okay, now let me shut down something and let me scale up something, right? So you can do that only in Kubernetes. In Linux virtual machine, it is not possible. Sorry, go ahead.
So
You had
this
a question?
automation, I see it, and this without using human effort also you can do automation to shut down your virtual machines, right? It's not like human
What
intervention is
software
must.
is that? Do you have any software for that?
like if I have experience from OpenStack, so if you can run those computing command like Nova and all those things, and then
Mhm.
you can run the automation and
Yeah,
you can do it. So it's like you don't require always the human intervention. And personally, human intervention, I don't see like human intervention is required for turning off VM. Why you think that human
correct,
intervention is
correct.
required to turn off the VM?
Then how will you do it? No one will do it for you.
I mean, like you can run this, you can create the scripts, like automation script that
Correct.
those will work,
So
like
that was
clone
my
jobs and
question.
all those things.
That is my question. See, you're speaking of theory, okay? It is not real. It is not actual. Do you know any company in the world which uses, even if they're using OpenStack, they shut down Linux server when the load is low? Do you know? See, you are speaking of a theoretical scenario, which is not real. Okay,
So,
and
I mean, you can tell me, Vijay, why
mm,
it's not possible? Means why the companies are not doing it?
everything is possible in IT. Okay, nothing
Okay. Yeah.
because there's Linux open source. Linux is open source. You can take the code, you can do whatever you want to do. Docker is open source, Kubernetes is open source. You can build a supercomputer, whatever you want to do. Okay, I'm the last person to say something is not possible, but there is this thing called, I mean, we have ground reality. Okay, nobody has done it yet. If somebody were to write such software, maybe it will become $1 billion company. We don't know that, but the ground reality is that nobody has written. And I'll tell you another relevant fact about OpenStack. OpenStack, unfortunately, no, not much people are using OpenStack. This is a ground reality. I'm telling you a fact. Even though I personally love OpenStack and I believed in OpenStack whatever 7 8 years ago, it did not pick up. It did not become a famous software. So maybe less than 1% of the world people are using OpenStack. Okay, so now even if you have a software to run it in OpenStack, the market size is tiny. So maybe nobody has written for that. Okay, so technically it is possible, but nobody has done it yet. Um, so that could be one of the reasons why people love Kubernetes, because Kubernetes does it for you, right? So
Okay.
this is
So,
a fact. Yeah.
yeah, Jay, then I will not take your too much time. So, but still, if I see the difference between virtualization and containerization, so
Mm,
containerization wins over virtualization at the operating level, at the operating this OS, they don't include it. That is one of the best thing they do it. So they somehow reduces those file size and CPU memory.
yeah.
But other things like auto scale, I see that is there in virtualization also. I mean, I'm not, I didn't, so like you say, I work mostly as a developer, so
Mm,
I never work as a like administrator and data administrator. So
mm,
maybe I won't know too much software. So, but
yeah.
I try to get answer for this question theoretically or only in reading document. But I accept this OS, I didn't get too much because this computing power and all those, I try to calculate at the end of the day, they will come up at the same value.
Okay. Mm.
So if you are handling a kind of large load, so but yeah, this is my understanding. But yeah, I won't take more
Yeah,
time.
so
Please
no, no,
continue.
it's okay. We can continue to discuss this. It's also interesting because still lots of companies use virtualization. Still, there's lots of Linux and Windows. Another 10 more years, people will use it, right? So you will see them. And so this question is relevant only. And as I repeatedly telling you, I want this to be very like interactive and discussion. And also, the one more point I missed to tell you is in Docker, because it's a container, it can run anywhere and everywhere. Like it can run on your laptop, it can run on Google Cloud or somebody else's cloud or anywhere it can run. But in Linux or Windows operating system, setting up the application in an automated way is very, very tough. See, there are tools like Puppet and Ansible to set up in an automated way. But then almost always there will be one or two things people will log in SSH to the server and make a change and they'll forget and then they'll not document it. Right. So that is why in the Kubernetes world and using Docker, there is one thing people call it as a analogy, that is a pet versus cattle. In Kubernetes, you will see that, okay, the example is um, in a cattle field where you have lots of cows or goats or any other cattle, if you have, if one of them gets some sort of contagious disease or it is sick, like one of the 1,000 cows, if it is sick or contagious disease, whatever, what people will do is they will shoot it and they'll bury it and forget it. Okay, they'll be happy, hey, at least we saved 999 of our cattle, life is good. But then if you have a pet, let us say you have a pet at home, some of you might be having. Now, if you are going to love your pet, take care of your pet, and something, if it is like not feeling fine, you'll people take it to the doctor. And recently, I heard like one of my friend was telling like there was a kidney transplant operation they had to do for their dog. I mean, they love their dog so much, they'll do like whatever they want. And then I've also seen a death of a pet animal at home is a very, very sad event at home, and it's a very traumatic. Okay, so these are the difference. Similarly, as a Linux administrator, for the past 20 years, I was taking care of all of my Linux servers like my own pets. Like I love them, I patch them, and if it is down for whatever reason, then I'm going to panic and I'm going to upgrade it and I'm going to patch it, take care of them with great affection and love, like my own pet. But in the Kubernetes world, honestly, you will see I'm going to mercilessly delete pods and scale up and scale down pods for for testing purposes, for demonstration purposes, and even in real workplace, like if there's a problem, I just delete a pod, and then Kubernetes in like one split second will create a pod in another node. Okay, so this difference also you should see. And taking care of an application or an operating system like pet is like human intensive, it is very expensive. Then you will always SSH into it, and you will take care of it well. But then if Docker Kubernetes, if it is like cattle, I will run 1,000. If one node dies and if 10 containers are vanished, I don't have a problem. I mean, not even I have a problem. Like Kubernetes itself is going to restart those 10 parts somewhere else, wherever there is compute and CPU and memory based on its scheduler. So that is another huge advantage I see in Kubernetes, where there is no secret or unknown things in my Kubernetes cluster, because my Kubernetes cluster, whatever the API supports, that's it. And actually, this happened today in my workplace. Somebody said, "Hey, we need to install the software on the node." Right? I clearly told them, "Hold on, nobody can SSH to the Kubernetes compute nodes. I will not even allow them to SSH, or I myself will not even SSH to a node. Forget about the pods. Even the Linux operating system, I will install Kubernetes. That's it. Then we will go to Kubernetes to deploy anything. I will even disable SSH for anybody else in the company, because nobody needs to connect to a Linux operating system uh, upon which the Kubernetes runs, right? So this is a commodity. The Linux operating system on which Kubernetes runs is a commodity. There is no special treatment to even one operating system, even if the Kubernetes contains 1,000 nodes. Every single node is just a cattle. Nobody cares. And you don't, I was really surprised, like 3-4 years ago when I started learning Kubernetes, one of the first things they said, hey, you don't even SSH to a Kubernetes server after your the nodes of the operating system after the Kubernetes is set up. It is just a commodity. So this is new way of looking at stuff, is what I'm trying to say. So that there is no special care for any operating system. They're just an operating system with an IP address and a host. No special care. Okay. Somebody else had a question, I think.
Jay?
Yeah.
Yeah. It's just like, I'll give an analogy,
Yeah.
make me correct if I'm correct.
Okay.
It's just like a single farmer doing a 1 acre cultivation, and you do an extensive Punjabi kind of farming with extensive.
In a sense, yeah, correct, yeah. So
Yeah,
you are
yeah.
doing at
So if
scale, yeah.
yeah, so when to say that if you have two of my saplings are going in a field of 1 acre, I'll be very worried.
Yeah.
If it is in thousands of acres, like if the
Yeah,
scale is large, we don't. I don't mean to say that in the sense
yeah,
for the sake of understanding, because
yeah.
as we will be very conservative, right? In that particular point, we think this is losing, but in a large scale, it doesn't matter.
Correct. Yeah. In a large scale, it doesn't matter. And also, the other
Okay.
point is, see,
Yeah.
we don't know when, let us say we are a website company and we are giving some service for the world. And let us say some website became a big hit with customers. Okay. Now,
Okay.
suddenly,
Okay.
there is only 1,000 people using any given minute. Now, there's a million people. Now,
Hmm.
in Kubernetes, it can scale up. You don't need to re-architect your application. You don't need to rewrite your code. Kubernetes is already ready, whether 3 people are using it or 3 million people are using it,
Fine.
right? So
Fine.
that is another huge advantage. You are prepared. If just 3 people are using your application, okay, just put 2 parts and then run it. Because you will configure in your horizontal part autoscaler that minimum equals 2, maximum equals say 100, right? So any application you develop, you are developing for the whole world. You don't know.
Yeah.
You're developing 10. As a company, you're developing 10 applications for 10 SaaS
Okay.
applications or whatever. Now you don't know which is
Fine.
going to be a super hit and which is going to be a failure, right?
Yeah, it depends upon the customer's perspective and the market
Correct.
demand or trend.
But
Trend.
you're not thinking about the architecture and scalability later,
Fine.
because your Docker container is only one. The logic is
Fine.
inside that. Okay. Kubernetes
Yeah, and
enables you. Yeah.
mm, and another two things.
Yeah.
Like, you know, it's kind of an analogy. Don't
Okay.
mistake.
Yeah.
Like earlier we've been having these BAI servers and WebLogic servers and all. So where we have the container, and the container will be doing this kind of creation of thread pools, right? So depending upon the load, it will
Correct.
create the pool of threads,
Correct.
and that too also is not that as agile as Kubernetes, right?
Correct. Yeah.
Yeah, one way it is analogy.
Correct. See, there also, I
Okay.
know many of this J2EE application
Yeah,
server, you
yeah,
can add no or whatever, add the containers and scale up and down.
yeah.
But then, see, that is an enterprise grade, cluster
Yeah,
aware
yeah.
J2EE application server,
Yeah.
right? So it is already cluster aware. Like it had the intelligence, and then there are also complex and expensive software. But
Yeah.
that you can do only for Java.
Yeah, got it. I'm just
Correct.
talking about only about the analogy part. So to
Correct.
understand better, like
Yes.
this is in the scope of virtualization, right? So that is in the plane of enterprise edition of Java breed alone.
Yeah.
Now this is again in the virtualization space. And another thing, as we to be rightly understood, is from this particular discussion with the Mr. So I don't know his name.
Okay.
The real question comes is like the same thing, like VM is doing better. Why to go Kubernetes? But there are real the performance stuff that need to be very clearly be justified. So we'll look into that particular point, I think.
Sure. And I'll tell you another ground reality statement. Like 4 or 5 years ago, I used to work for one of the largest retail company in Canada. So there, this November, December time is the peak. So we used to have 10 servers for one of the application which they had.
Okay.
Now, remaining months, right? I try
Okay.
to negotiate with him. Hey, look, only November, December, you need this 10 servers, but
Mhm.
for the remaining 10 months, you are effectively using only one server capacity. Like
Mhm.
90% you are wasting. But yes, I
Mhm.
agree. November, December, that too, that Black Friday, and only couple of days. You are using 70% of the 10 servers. Okay.
Mhm.
But then the senior management of these people, like, VP level,
Mhm.
AVP level, there is also a little bit politics here, right? So that
Yeah.
AVP will think, why should I release my compute? I don't want.
Hmm.
This application should be ready for my Black Friday sale, even in January. Now, how do we
Okay.
negotiate with him? And these people are all in company. Some people have political power, and they think, hey, releasing my compute for the 10 months, it means that they're like losing some pet, like donating their own money and CPU. I told them, look,
Yeah.
even in October, I can ensure I'll give you this 8 server capability to you, but allow me to use this 8 servers for other application, right?
Yeah.
And I could not win. So there is also
Yeah.
politics in play here, right?
Ideologies different.
Yeah. So an AVP of a company who takes care of this division, he want to maintain his power, and he say, hey, look, I have 500 servers running, so I'm a big deal. So there's lots of politics involved. I don't want to get deeper there. So unfortunately, and this is a ground reality, right? That I'm just an architect. I cannot go and fight with the associate vice president of a multi-billion-dollar company saying that, hey, like you're wasting resource, right? So now,
Yeah.
as the previous person was talking, it's not all decisions are done based purely on technology.
Yeah. There
There
are
is
other
politics
factors.
involved,
Other
there is egos
factors.
involved, right? There is
Yeah.
licensing cost is involved, legal issues are involved. There are so many things we
Yeah.
should.
Until we land up with some real mishaps and learn that how to be done.
Right.
Maybe this might be a lot of experimentation and research, and then it's been universally accepted.
Yeah, I mean, so even though technically we think, hey, I have Linux virtual machines, why don't I shut down and reboot? But then the business people will think as though we are stealing something from them. They're not even agreeing.
No, actually, that's that for them. Millisecond or microseconds or a fraction of seconds is their business. They don't want to get
No, but
worried
not in
about.
the 10 months, not in the first 10 months of the year.
Fair.
In the first 10 months
No,
of the
yeah,
year, they're only using one
yeah,
server, kept
yeah. They
worth
don't
of
bother.
capability.
Yeah,
Correct,
still they don't bother.
correct, right? So there is
Indian
effort.
mindset, we bother.
Yeah. Okay, fine.
Yeah, we should
If
continue. We shall
yeah,
continue.
if there is no other
Thank you.
question,
Thank you.
uh, yeah, it is good that next slide extends on what we have been speaking. See, Kubernetes itself, some people call it is like the Linux kernel of distributed systems. See, now let me deviate for a second. This is a website I'm following from the past 20 years. This website lists the largest supercomputers in the world, and they generate this, I think, twice in a year. And then you will see, like, what are this supercomputer in Japan? They got like 7 million cores of CPU. Okay, and it has got 442,000 teraflops. Okay, this is the world's greatest supercomputer, and this is US IBM, which is used in this national lab, and the third one is in US, and fourth one is in China. Okay, so I always watch this, and when it started 20 years ago, it used to have some Unix servers and some Linux servers. But now, from the past, like nearly 10 years, nearly 100% of the servers are Linux operating system. Like there's no Unix, there's no Windows, there's no Apple, there is no other operating system. All top 500 supercomputers in the world use Linux for their compute. Okay, let me see if I can show you the operating. This guy, the biggest supercomputer in the world uses Red Hat's Linux. Like it's all Linux only, Linux kernel only basically. Whether it's from Red Hat or SUSE, that is less important. So, and all of our Android phone is a Linux kernel based Linux computer. I hope you all know that. So, beginning from Android, which is like tiny as the thing which we carry in our pocket, to the greatest supercomputers in the world, all use Linux, which is free and open source. And so the point is, Linux can be morphed to run on the tiniest of the computer to servers and data centers and cloud and the biggest supercomputer in the world, right? Because it's open source, anybody can take, people can remove whatever they don't want and they can customize it, minimize it, or if they have good developers, they can add whatever the new capability you want for Linux, and then you can extend it. Okay, wait, let me see if I can get you based on the operating system family. I've not seen this recently, so I'm curious to see if there is any non-Linux. There is an IBM. You know what? Let us even see operating system. Okay, I'm curious to see if there is anything which is not Linux, right? So I think it's all Linux only, right? There is nothing else we can choose also here. CentOS or Red Hat or Cray Linux. Yeah, so mostly it's all Linux. So the point is, because Linux, people take Linux and do what they can do whatever they want. Similarly, Kubernetes is also a software which is free and open source. You can take it and and it's written in Go programming language. If you are not happy with the scheduler algorithm, you can rewrite it the way you want it. And if you want to add some component, you can add whatever you want to do. So now Kubernetes is like the Linux kernel, but for distributed systems. Linux kernel is one, big piece, which is one whole piece. But then Kubernetes being a distributed system orchestrator, you can do whatever you want with Kubernetes to customize for your company need. But then 90% of the cases, the stock Kubernetes, whether hosted on the cloud or on premises, is sufficient. But then the advantage is that there's lots of companies doing research on Kubernetes and they're extending. And because it is free and open source software, they're contributing the code back to Kubernetes. So it is expanding every single day. Like people are adding more capabilities, more alerting and monitoring, high availability and multi-cloud, right? So lots of innovation is happening in Kubernetes now. So it is growing every single day people are adding, and there's hundreds of companies which is contributing to Kubernetes. Okay, and the second thing I want to add here is that obviously I've been speaking about it being an orchestrator, and the third thing is it's a framework to build framework, right? See, Kubernetes has got all these capabilities, but then if you want to take this framework and add few other components and framework, some sort of um, grid computing capability or something else you want to build and add, you can extend it because the source code is free and there's lots of knowledgeable people from every country in the world who has looked at the Go source code of Kubernetes and how it works. So if you want to have your own framework based on Kubernetes, you can hire a few Go developers and then you can start developing, right? And the another thing is, see, Kubernetes is, even though it's released like 6+ years ago, even before that, for more than 10 years, it was running the whole of Google, the principles and the ideas. So I personally think now, even if you want to build some orchestration tool or some tool which will take care of your infrastructure in a reliable way, even if you hire 500 best developers and operations team and build lock solid and automate every single day whatever you want, after 10 years you will end up with something like Kubernetes. This is my personal opinion. So if we start using Kubernetes today, it is as though we will go ahead by 10 years, right? Because whatever problem you're going to solve, Kubernetes has already solved for you. This I can also say based on my experience as a operations person managing thousands of Linux and Windows servers in data center. When I look at Kubernetes, I say, hey, these are the problems I had. Kubernetes already solved it. So why should I even go back to Linux, Windows, or virtual machines and all those things? I don't want to go back because Kubernetes has solved all my problem. Like in real. and it is battle tested for more than 10 years at Google scale. And that is the reason every single vendor in the world, believes in Kubernetes and trusts and migrating their application onto Kubernetes.
Jay,
Okay. Yeah.
It's just like, as you told, it's just like 10 or 15 years back, we have been using, we have started with OpenStack.
Okay.
And we built a Rufai node cluster private cloud in our premises, in our college.
Okay.
So it was a team of 4 students and 2 faculty, and we were struggling for 6 months. We started from the base, scratch of Linux administration. We were zero in that Linux commands and administration.
Okay.
And even bridging, we don't know what is bridging.
Correct.
So for
networking.
moving the images around, they wanted a bridge connection and a high speed switch.
Okay.
You'll be having the glance, right, to the registry, things while we're storing your VM images. We need to move them all together. And now, as with Dockers and this thing, that 6 months of the learning curve is reduced to 6 minutes.
6 hours, let us put it.
Yeah, maybe hours, maybe hours. Yeah, maybe hours. And I what I learn here is that this is what is the scale which we are exposed to when it comes to an enterprise. Like where you have millions, maybe in scales of thousands of millions of Dockers, then Kubernetes, as like you have a lot of intricacies, and what do you mean by the repetitive administrative tasks and scaling and call of all operational related activity stuff. It has been, they have foreseen and they have made it as all available, APIs available. Correct. So pick this one to scale this thing. Security problem, have this. So it's all about like how you take and fit in and do how the orchestration does.
Correct. Yes.
Fine.
Yeah, I know. I also dabbled with OpenStack. I also set up here in Calgary many years ago. It is not for the faint-hearted. Even with like more than 10 years of Linux administration experience, it was not easy for me. All the components, and then the other problem is I set up in a lab environment, and then in the whole company, I'm the only OpenStack person now. So am I supposed to take care of it 24/7? What if I want to go on a vacation?
It's you're the sole
It is my pet.
proprietor, sole responsible.
Yeah. So I just moved out of that whole OpenStack. Thank you. Okay. So now the other thing is there's a huge ecosystem. If you search for Kubernetes now, you'll get like million hits. It is not that like OpenStack, right? Or if 1% of the world uses, and then that too rarely, then you'll not get support. But then now you go to Google and support any like Kubernetes services configuration or anything, there is like tens of thousands of hits, sometimes millions of it. So there's a huge ecosystem. You are not doing it alone. There's like 100,000 people. Like some of the conferences, Kubernetes conference, I went to US 3 times. There's like 8,000 people, 12,000 people. That is the number of people who physically come. And like this KubeCon, I was in Los Angeles this month only, November month, and there were like more than 3,000 plus people. Even though this is COVID time, then virtually 25,000 people joined for this 5-day conference. So there's a huge ecosystem, which we are going to see in a few minutes. And then it makes shift left possible in CI/CD. See, generally, even based on some of the 3D animations you might have seen, there is developers. Oh, you know what? Let me see if I can quickly bring this screen, which I have it in my other window. So you have developers who will deploy to this environment, and then testers will test it, and the users is going to use it. And obviously the operations people has to set up everything initially. When operation people set it up, developers will use, testers will test, and then you have the users. Now, if you see, the ground reality is, as most of your developers, to get any compute resource, whether it is a server, whether it's a virtual machine, whether it's adding disk or access or anything, it will take anywhere from 2 days to 2 months. depending on the company you work, right? If you want to have a Linux server, I know many companies, it takes like 6 weeks, 2 weeks to 6 weeks from the past, like, I'm speaking like uh, uh, 20 years, but now people automate it. It is virtualized environment. So you'll get it in a week's time if you want a few Linux servers or Windows servers. And if you want to have disk, you have to create a request and then somebody has to fulfill it. So there's a there's a delay for infrastructure. But in Kubernetes, if the cluster is ready, you can deploy it and it will auto scale and taken care. But to come back to this point, what shift left means is that um, the freedom for the developers is more in a Kubernetes world. Developers can build and deploy every single minute to the pre-prod without asking or telling anyone. And if the code is ready, it can be like reviewed and released in Kubernetes, because as you might have heard, in Kubernetes, the releasing is non-disruptive. If you want to upgrade your application, Kubernetes will ensure that if it has got like say 10 pods, it will stop the request coming to pod 1 and it will empty it, and then it will replace with the new application. Then it will stop the request coming to the second, and then it will replace. Rollover replacement is going to happen. So you can release anytime you want. You don't need to wait on that Sunday morning 4 a.m. You will get a downtime. No, not anymore. You can release 24/7. And I've heard companies like Netflix, they release like hundreds of times every single day, because the code is already in some sort of Git repository, and then it has already been tested in a non-prod environment. Somebody has to click a button and then it will be deployed in a rolling manner without even people watching videos. They will not even know. So those things we are going to see later, but in a high level, this is the point I want to make. Developers will have humongous freedom now. They have zero dependency on the operations people. They can deploy whatever they want, whichever way they want it, whenever they want it. They need not wait for any operations people for CPU, memory, disk, any of those things. Obviously, access you have to wait, but then once you have access, you can release like 20 times a day in a dev QA or a pre-prod environment. And if it is ready, you can also release to production, because production is non-disruptive. Okay, that brings to the next point. No Linux administrator. I mean, in the sense, there is nobody to administer Linux operating system, because these are all not pet but cattle. You can Linux administrator job is to have a cookie cutter configuration to install Linux operating system and then just add it to a Kubernetes cluster. That's it. Like there is no title like a Linux administrator, because it is a standard operating system. Any developer can set it up very easily, even if it is required. Like you don't need deep Linux administrator knowledge needed, but you need Kubernetes knowledge, but not Linux, because you're not even SSHing to a Linux server to do any administration task. And siloed operations people is not going to be there, because it's just a YAML file. A developer can deploy to any Kubernetes cluster. And one of the reasons why I moved to Linux, like more than 2 years ago, full time working, is because I saw as a Linux administrator from 20 years as a Linux project architect and whatever I was doing, I saw I'm going to lose my job, because nobody needs a Linux administrator anymore. So that is why I have to shift to cloud and then to Kubernetes. That is an interesting point of view. And last point is, nobody can stop a developer from being productive. This is maximum freedom to developers, because they can release their code or algorithm or framework or logic. When business wants it, hey, add this functionality, developer can start coding and he or she can start deploying in a non-prod environment the same day. Obviously, if code is tested and validated and approved, they can release to production same day, right? So these are all some of the advantages and the way how Kubernetes works. I spoke about the ecosystem. This is a huge ecosystem. This we are going to go in depth later. And then where does Kubernetes run? Kubernetes can run in your on-premises data centers or managed by cloud vendors, which they're all charging only 10 cents per hour for the cluster plus cost of compute nodes. And there's Minikube, which you can install on your laptop, desktop computer, or if you have a small Linux server in your data center in a development environment, you can install it. So, and there's like multiple distributions of Kubernetes, which we are going to go later. You will see like there is one Kubernetes, which the whole of Kubernetes distribution is like 1.4 MB that will fit in a old floppy drive. The whole of Kubernetes, it is just like, less than 2 MB. So people have stripped out all unnecessary components of Kubernetes. The core Kubernetes only they have. There's a distribution which is, I think it's called K3s. Okay, if you really want to run it in like 2 MB, you can run Kubernetes with the core capabilities, not all capabilities. The core of Kubernetes for testing purpose, you want to run on your laptop or desktop on a small machine. You just need 2 MB of space and RAM, and you can get a Kubernetes up and running. And now we have only 3 more minutes for 9 o'clock, right? So I will try to end this in 3 minutes. Okay, so now some of the Kubernetes capabilities are, this is the new data center operating system. You can think in that way. And all services within Kubernetes are natively load balanced. Like you cannot deploy a deployment without like load balancing, because it's an inherent capability of Kubernetes. Because in the olden time, we will set up a Linux server and then people will access it. And then if that Linux server goes down, your application is down. But in Kubernetes, you can't even connect to a pod, like we will only create a deployment, and even if you have one pod, it is self-healing in the sense, even if you delete that pod, Kubernetes will see, hey, look, uh, the deployment configuration says there should be a pod, but this pod is not there. So within a fraction of a second, it will recreate a pod if that node is not there to another one. So by default, it is like load balanced and self-healing capability, and it can scale up and down and uses the same API for bare metal, on-premises virtual, public cloud, or as we spoke, a 2 MB Kubernetes cluster. Everything uses the same API, and that certification is given by the CNCF Foundation. You can have like jobs or scheduled cron jobs you can have, and you can manage stateful application. Generally, the databases are called as stateful, that we will see later. And then you need not worry about, okay, I've deployed my application, now how do I make other application to discover this? So there's a concept of services, where in which if you create a service, then it will go and discover all the services, and then it will route and it will take care of all those things. And there is like declarative and imperative way of deployment, which we will cover later. And then the application deployment, which is the default, you can have 4. Like if you want to upgrade, then you can recreate your deployment, or you can do a rolling upgrade, which we briefly spoke, or blue-green deployments, one which half of the server, let us say you have half of the server and another half of the server. You'll add another half of the server, pods, and then you'll delete this, and then you'll migrate the load here, and then you can delete the other half also. That deployment is a capability. And then canary deployment is also a type of deployment you can have. And I have many more slides. Sorry, I missed focusing on the time. So I don't want to take too much time here because it's 9 o'clock there. We should continue tomorrow, I believe. So I will end this recording for now.